Okay, now we're going to look at angle in a semicircle and look at a question that's a little bit more challenging that combines a few different ideas. Now, let's see. The angle in a semicircle, what's that one about? Well, the angle that subtends the diameter of a circle, that opens up to the diameter. Well, there's the diameter from H to K. It's always 90 degrees. Well, that's the reason. But it's kind of interesting to look at. Why is that true? You know, it relates to the angle at the center. You see, it opens up to this segment of the circle. Well, that's 180 degrees at the center. Right there, that angle is 180 degrees. Whoops, 180 degrees. Well, the angle at the circumference must be exactly half. That makes it 90 degrees. So that's why any angle that opens up to the diameter of a circle, which is opens up to the segment which is half the circle, a semicircle, an angle in a semicircle must be 90 degrees. Now, here's a question here that's a little bit more challenging in the first part one part of all those questions. You've got this ACB situation going on here, and you know that that angle is 108 degrees. Well, you could get that angle with the angles in a straight line. You know that that's M, but you're supposed to figure out M. And if you just look at that, you get, oh, I don't see it. I mean, wow, I don't know what that angle is. But hang on a sec. AO and OB, they're radii. They're both radiuses. That means they're exactly the same. Because these are both the same length, the distance from the center to the outside of a circle is a radius. That means that angle A over here must equal M. So those are both M. Because angles opposite equal sides are equal. And you have to give the reason there. You even have to give the reason why OA equals OB, because they're radii. Well, that means this has to be 36. All you have to do is go 180 minus 108 and cut it into two pieces. Divide by 2, and you'll get M is 36. You could make an equation, 2M plus 108 equals 180, and solve it. You'll get M equals 36 because the angles in a triangle add up to, the angles sum, and it's good to name the triangle, add up to 180. Now let's take a look at this one. Oh, for the same reason here, angle OBC must be equal to angle L. Angles opposite equal sides. Because OC is equal to OB, they're radii, then that must be true. Well, you can say right away that OBC, actually, you don't need that there. OBC is equal to 54 degrees. OBC is equal to 54 degrees. Actually, you do need that. We need that those two are equal. I know that that's 54 degrees. Why is that? Well, we know that M is 36, and we know that this is a diameter here going through the center. So that's got to be 90 degrees. Well, 90 minus 36, that means this angle must be 54 degrees. I'm wrong. We do need that thing right there. OBC is equal to L. And we know that that's 54 degrees. Well, therefore, L must be 54 because equal angles opposite equal sides. This thing here, that must be 54. Now you could look at the video, look down here a little bit later and take a close look down here. You wouldn't have had to use angles in a semicircle to get at L. You could have got L doing something called the exterior angle. Maybe I'll just go over it quickly. You just go OC equals OB. So they must be equal, but we've already done it. Equal angles opposite equal sides. And these two angles here are add up to this exterior angle. Well, half of 108 is 54. So these two must be 54 because the exterior angle of the triangle COB. Hey, that's another way of looking at it. Look, a different reason. So there you go.